Jacob. All right, we're talking about satellites today. And I know everyone, when you got here, totally circled this past Tuesday on your schedule because you were like, wow, awesome satellites lecture by Josh. And then it got postponed 2 days and it broke your heart just a little. But now we can actually get this done and we'll make it as painless as possible. Satellites, interestingly enough, are either, I think, a really major part of the topic or are going to be barely a part of the topic at all. And that's going to come down to some issues, I think, on topicality and how things wind up sort of getting interpreted as the season progresses. My money is actually on the latter, which is that they will not be a very huge part, or at least some of the better affirmatives that you could read regarding satellites, but that's just my guess. I can't tell you how things are going to work out. So, continuing on, satellites. Anybody know what this is? Sputnik. When was that?
1950.
Right. First satellite, first space exploration that actually goes into outer space. Where in outer space might that be? Let's keep it going.
Beyond the mesosphere.
Beyond the Earth's mesosphere. It would not do us very much good if it was some other planet. But Sputnik is our first satellite, right? Russia puts it up. It doesn't really do much. It's this shiny globe. It's got 3 antennas on it, and it just sends out a radio signal. And pretty much everyone the world over completely freaked out when it went up because they thought it was going to shoot like death rays and destroy things and precipitate yet another, or actually an earlier missile crisis in this instance. So that kind of raises the question ultimately, and what today's big question is, right? And that is, so what? Why do you care about satellites? What is the big deal about them? Why are they particularly relevant to the debate topic at hand or anything like that? You want to talk about mining Mars or causing asteroid deflection or something like that? Well, here's the really simple answer, all right? That is more than 95%, in fact, closer to 98% of all of the launches we have done into outer space, beyond the Earth's mesosphere, have been for satellites. The overwhelming, and I mean really overwhelming, amount of space travel that has occurred isn't done by people, it's not done doing any of the cool stuff. It is the day-by-day of satellite launches up that orbit the Earth, all right, or some other spots we're going to get to in just a bit, all right? Which means that in terms of the stuff that we have talked about, but for the labs that are reading the solar-powered satellites affirmative, all right, most of you are dealing with the minutia of space exploration, the smallest little details. It's the cool and sexy stuff, all right? But honestly, the overwhelming majority of it, really completely uninteresting. That was until this morning. There are 3 things, all right? 3 things that you ought to care about, I will argue, minimally. And beyond that, you may care about more if you like. But these are the 3 things I would like you to be thinking about as we talk today and going onward about different satellite stuff. That's a technical term. First, what are the kinds of satellites? There are actually quite a few of them, and they exist in a bunch of different places. Everyone kind of has this idea of like all these little things clustered closely around the Earth. Actually, not true at all. Most satellites are quite far from the Earth. Secondly, which of these could arguably be topical affirmatives? All right? There are about somewhere around 3,000 satellites total right now, orbiting the Earth and doing all sorts of satellite-y stuff. Another technical term. Which of these are potential apps? Which of them are potentially topical? Which of them do you care about and want to strategize about? Which raises part number 3, strategic considerations for the affirmative and negative. All right? What do you need to know? What is the sort of minimum floor of stuff you should know in order to be able to successfully debate different satellite issues on this topic? If you are interested in learning more about satellites beyond what you need to know, I guess Wikipedia is a good place to start. Beyond there, do whatever you want. So, without further ado, part 1. What the heck are satellites? Anybody? Yes.
They go in a circle around the Earth.
Go in a circle around the Earth. That's definition 1. Go ahead.
Artificial beings that are like circle around the Earth.
Artificial beings that kind of go up and circle around the Earth. We put them up there. Yeah?
Anything that rotates around the orbit.
Anything that rotates around, and I didn't get the second half.
A planet in space.
A planet in space, okay, so it rotates around the Earth, it can rotate around a planet, it's in space, it's artificial, it's put up by humans. Sends information up and back, potentially, yes?
They're not all artificial.
not necessarily human-made. That's possible. I'm going to propose a definition that I think's pretty okay. It's not the be-all, end-all, and it's actually a little bit more limiting, maybe, than we thought at first. All right, and that is that a satellite, all right, is an object which has been placed into orbit, all right, by human endeavor. Which I don't know. That sounds like some speech like JFK gave or something. But I don't know who says endeavor. But orbit, human, space. All right. These are the things that kind of matter here. All right. So a satellite is an object which has been placed into orbit by human endeavor. I think those are pretty meaningful definitions. It's a good space for us to kind of start. So continuing on, maybe. Well, that's all for today, so everybody have a good morning. It was not good. All right, let's try again. Oh, we got it working. We're just going to do it manually. So, back on what? All right, so here's a good question for you. That thing in that picture there, is that a satellite?
No.
It's a satellite of Earth.
Not by your definition.
Not by your definition. Actually, I
Good question. Right? It orbits the Earth, right? But just for those who are playing at home, what is that? Huh? Yeah, we got it's the smooth. It's a little sun, it's a little moon, whichever one you want. We're gonna go with moon, just for the purposes of this exercise, though. All right. You know, it could be the light bringer. You might worship it. I don't know. It might cause your transformation into Teen Wolf. But either way. All right. So it's the moon. So it orbits the Earth. It moves in like a somewhat circular or elliptical pattern around some other thing. It's out in space. It's assuredly beyond the Earth's mesosphere. Otherwise, this would be a really boring topic. Okay, so, I think our answer is kinda. It's a satellite. It's sort of the scientific, technical definition of the way those things work before we made our own and put them up there. But I'll propose something else for the purposes of today's lecture. It's not really the kind we care about. Yeah, technically all planets and everything are satellites, and we talk about the Earth orbits the moon and whatnot. But we don't really care. These are the ones we're going to care about a little bit more. All right. This is what we're talking about here. All right. These are the things that go up on the spaceships and then orbit around the Earth and send communications back and forth like we talked about. And just in case, that's actually what one of the XM Sirius satellite radio things looks like. They're made by Boeing. I got that off their website. They're fine people at Boeing. Help me out here. So, types of satellites. And this is going to be the sort of guide we're going to use here. So, there's 5 or 6 types that we're going to really care about. And I think are sort of relevant for different topic stuff and can potentially make some interesting apps. We're going to sort of use these as our guide for the rest of our discussion today. All right? The first type are observation satellites. All right? In parentheses, I call them spy satellites. All right? Basically, these do 2 things. Number 1 is they make Google Earth possible. All right? You can take photographs of stuff from space with them, and then you can Google Earth stalk your friends and see what their yard looks like. And, am I the only one that gets on Google Earth and looks at every address I've ever lived at and places to see if I can see my car or if I'm in the yard or anything? Does anyone else do that? Good. Has anyone been? I found my car outside one of my apartments, so it's kind of odd. Has anyone else found themselves on Google Earth? Yeah. From space, you're like, hey, that's me, or and I don't mean your house, right? Your house is something that was your car or anything. I was really excited when that happened, but that's because I'm really easy to please. So yeah. Anyway, Google Earth. The other thing that they do is they're spy satellites. All right, a significant number of the satellites in near-Earth orbit, all right, belong to the Department of Defense of the United States. Hundreds of them. All right. Has anyone ever seen the movie Patriot Games? All right. I'm really dating myself here, but yeah, I don't even know why I'm going. This wouldn't have worked 6 years ago at camp. All right.
I've seen it.
Huh? Whoa. Yeah. There's the scene where they attack the Irish. The IRA doesn't even exist anymore. Why am I? That's how dated this is. Wow. Really? Wow. Anyway, so yeah, spy satellites. Basically, the Department of Defense is quite literally capable of looking at anything on the planet with plus or minus within about half an hour's time, down to a detail of 2 to 3 feet. All right? A few of the satellites that they put up, arguably, if I was holding a sheet of paper right here from space, if I had anything on there font size 14 or above, some of our satellites could read it. All right? And they're smart enough that it's not just they can take a picture, they can legit read it. All right? Like over-important intelligence assets, we will literally position those things. They will read any text they see, and if it's troublesome, they'll call home and be like, hey, you might want to check this out. All right? Now, most of them aren't that precise, but we use them for doing a lot of spy stuff, honestly. It's a little bit easier than putting a person on the ground because you sort of stick out like a sore thumb. Second type of satellite. This is the second most common. These are communication satellites. So, phone, internet, etc. We use satellites to do a bunch of stuff. I didn't really make a graphic for this, but I'm going to draw a human picture here. Imagine this is the Earth. All right, if you want to send a message from this side to this side, there's a big planet in the way. So you use the satellites and you bounce it around. Pretty simple concept. I didn't think I needed a fancy animation for this one. But it allows you to do a lot of things because you can go around the planet using them because going through it is very difficult. Third type, navigation satellites, GPS. All right? There's 3 major navigation systems. There's the Global Positioning System, that's the American one. And then there is a European one, whose name I looked up last night and forgot. And then a Russian one, which I cannot pronounce. All right? What you need to know is that the most commonly used one is the GPS system. It's comprised of 24 satellites, and I'll show you a cool picture about where they are later. Fourth type, weather satellites. Lots of these, particularly parked over the United States, North America, and several of them over the Pacific and Atlantic Oceans. They monitor different things, they measure temperatures, all sorts of surface data and stuff like that. Cover them more later. Final kind are research satellites. All right? And these are sort of a catch-all for everything else. Somebody guess an example of what a research satellite might be. I'm sure you've actually heard of several. Harley.
International Space Station?
International Space Station would count as a research satellite, yes.
The Hubble telescope.
Hubble Space Telescope, also another one. Chandra X-ray Observatory, those sorts of things. Now, there's a difference between, say, Hubble, though, or the International Space Station, or the X-ray observatories, and everything else I've mentioned. What's that difference? Never mind, sorry, is not a correct answer. Yeah.
People can be on them.
People. Okay, yeah, there's no one on Hubble, but yeah. But people can be on the International, yeah? I mean, well, last time I checked, there wasn't anybody inside, like, the DirecTV satellite.
They study space rather than the Earth.
Ooh! Speak up and say it again for everyone.
They study space rather than the Earth.
Where are they looking? Right, Hubble looks out. The rest of these are all looking or concerned in, back at the Earth. This is going to be a very important distinction that we will discuss subsequently. Now, the bigger question is where on Earth are these satellites? All right? It's kind of interesting. There's 3 types of orbital altitudes, all right, that you should care about. And the text on this is how difficult it is to describe how far. All right? The little blue space here, all right, that's the LEO zone. That's low Earth orbit. And you can kind of see the white lines. The closest one, that's the surface, right? You can figure that out, right? And then if you went like less than 1 pixel up, that's as high as any plane ever goes. All right? A couple more pixels up, all that stuff. All right? All within this space right here, okay? You've got the surface, as far as any of you are ever going to go in your entire life in terms of altitude, the International Space Station, where the space shuttle goes, where Hubble is, where all of this is all within this first, pretty good, great, couple inches on here. Once we get out to about here, that's about 2,000 kilometers up, we move into the green zone, which is medium Earth orbit. All right? Here, now, all the way out here is where all of the GPS satellites are. All right? And here's an interesting fact. All right? And this is meaningful for where you put a satellite. The closer in you get, the faster stuff moves around the planet in terms of its orbit, such that